everyone, welcome to my channel. So today we are going to learn the chapter number 7 of class 8, that is pressure. Concept of pressure. Whenever a force is applied on a body, it generally acts on a certain area of a body. To measure the effect of force, we need to take into account both the magnitude of the force and the area on which force is applied. Well, there is a huge difference between the force and pressure. The thing is only that force is applied on a large scale while the pressure is applied on a unit per area. So, imagine a rectangular box over here, and this is a small area. This is a large area. Therefore, small area, large pressure, and large area, small pressure or low pressure. So here on figure 7.1, the pressure is applied into more quantity as compared to figure 7.1b. So, the magnitude of the force acting normally on a unit area is called pressure. If force acts normally on an area, the pressure is given by pressure is equals to force upon area. If we want to find how much pressure is applied on a particular object, we need to divide force and the area. So here it is given like this. In figure 7.1a, the force weight of block is acting on a smaller area, therefore the pressure is maximum, as I told you. And whereas the pressure in figure 7.1b, same force is applied, weight of the block is also same, but it's acting on a larger area, therefore the pressure is less. When the force acting vertically down or normally to the surface under consideration is called thrust. When force is acting on a vertical downwards, like over here, vertical downwards, that pressure is known as thrust. Therefore, pressure can also be defined as thrust per unit. If you want to find the pressure, you can write thrust upon area. Unit of pressure. The SI unit of the pressure is Newton and the area is meter square. Therefore, the unit of pressure is Newton meter square, or you can say Pascal. Pascal. From the relation, pressure is equals to thrust upon area. Thus, we can conclude that pressure is directly proportional to the thrust applied, and increase in thrust causes increase in pressure. Thrust means in area. Okay. Increase in thrust, increase in pressure in such a way that thrust is doubled. The pressure also doubles and vice versa. Pressure is inversely proportional to the area on which force is applied. And area means an increase in area of contact causes decrease in pressure and increase in force. Okay, and like this. Let us take the following example to understand the fact that decrease in pressure, increase in pressure, or conversely. An example is in area decreases the pressure. We all know large area decreases the pressure. For example, I'll just explain the activity number 1. For example, you take a board, for example cardboard or any wooden board, and take a nail. Now just take hammer and just apply or just hit on the nail. Hit the hammer on the nail. Then you will be able to see that the nail will penetrate easily inside the wooden thing. Okay. So why? Because the pressure applied is more. Therefore, it will easily penetrate inside it. Okay. Now here one example is there. The cutting instrument like blade, knife or axe, etc. have cutting edge very sharp. So it helps in decrease in area, in contact. Therefore, increase in pressure will be there. One more. Heavy trucks are are having 6 to 8 tires instead of 2 or 3 or 4. This is done to increase the area of the contact. Now, if the less tires will be there, then more pressure will be there. Then the tire will burst. Okay, therefore, to just give the equal amount, therefore tires are added more amount. Between the tires and the road, because of the pressure on the ground is reduced. Animals like camels can walk easily in the desert as compared to horses, because camels are having a broader feet, so that it will decrease in pressure. Okay, skiers use long flat skies to slide over the snow. Because the larger area of the contact, the lesser pressure on the snow. So this helps the skier to slide comfortably without sinking in the snow. The foundation of high-rise buildings are kept wide so that they may exert less pressure and they may not fall on the ground, or they may not sink in it. For example, here's one example. A solid weighs 80 Newton, then placed on a surface area, contact found to be 1.6 meters square. What is the pressure? Pressure is equals to force upon area or thrust upon area. Force is 80 Newton upon area is 1.6. Then just divide it. You'll get the answer. A rectangular wooden piece weighs 25 Newton if it is placed in such a way that its 25 centimeter length and 10 centimeter width are in contact. Then what will be the pressure? Of course, here this area or this length and width is given. We have to find the area. Then we will easily do it. So here the solution is given. Now pressure due to liquids means how liquids are exerting the pressure. So you just read this like a liquid exerts pressure according to the base of the container. They acquire the shape, whatever the shape of container is. So according to that, they are applying the force. So over here, this is a manometer. Manometer is used to measure the pressure applied by liquid. So over here, you can see that this is the thing, and liquid are exerting pressure. As we know, in oceans, when we go deeper, the pressure is high. Okay, when we go deeper in ocean, the pressure is high. So thus, the atmosphere is also exerting the pressure, while the water is also exerting the pressure. But as we rise up, the pressure decreases. Why? Because the atmosphere, we just cross the atmosphere, therefore atmosphere do not exert much pressure, and even we feel comfortable when we go up as the pressure is decreased. Okay, increase and decrease in pressure means huge increase and dramatically increase and decrease in pressure can cause severely pain in humans. For example, I'll give you the example of this. If we go up, then what will happen? If we go up, the oxygen decreases. Therefore, we won't be able to breathe. The bleeding will start from the ears, eyes, nose, mouth, and whatever the things are there. Because our body is exerting the pressure in that much amount. But from outside, our body is exerting pressure from inside. But from outside, the pressure is not being exerted. Therefore, there will be unbalance in pressures, and this will cause severe damage. Therefore, pressure should be in balanced way. Notice the walls of a dam are specially thickened and broadened at the base than the top, because as we go deeper, the pressure is high. Therefore, to make balance in the pressure of water, the withstand is huge. Okay, liquid pressure depends upon the density of the liquid as well. Bigger bulge is produced by water than kerosene. So you'll observe that the bigger bulge is over here. It is produced in a tube A due to water, and this is a smaller because it is kerosene, because it has a higher density. Water is heavier than kerosene, therefore higher density, lower density can also increasing pressure. So liquid pressure has the following characteristics. Liquid pressure increases with depth, as I explained to you. The second one, liquid pressure remains the same in all directions. Above, down it is gravitational, other centrifugal, and above, beyond. Liquid pressure depends upon the density of the liquid. A liquid seeks its own level. Now here the liquid is added in different types of shapes, and irrespective of the shape of the vessel, the water is taking its shape accordingly. Transmission of pressure in liquid. Transmission of pressure in liquid was first observed by Blaise Pascal, a French physicist, and he is known as Pascal's law. This transmission of pressure in liquid is known as Pascal's law. Now, according to Pascal's law, the pressure exerted on any point in enclosed in liquid is transmitted equally and undiminished in all directions. Now, over here, that can be demonstrated by the following. Here, one glass tube is over there. It is having piston at one end and a round bulb. Okay, piston at a round bulb. The round bulb has some holes in different way. It is having the holes, like this is one hole, this is one hole. As the pressure is given, the liquid is coming out. So consequences of liquid pressure. We know that the pressure exerted by water in ocean increases with depth. Very deep down, the pressure is enough to crush the human body. That is why deep sea divers wear special suits which are withstand such high pressure. Therefore, the fishes are having the streamlined body structure. When the deep fishes are brought above the surface of the sea, like deep fishes are found very deep in the ocean, their body flow at the high pressure. At the surface, the pressure is low. Suddenly it is decreased, but they are exerting the same pressure. Therefore, the body bursts open. Therefore, the submarines are built in a hard, thick sheet of metal to withstand the high pressure underwater. So, hydraulic machine based on Pascal's law. Figure 7.10 shows two vessels A and B of different sizes. So where is that? Okay. So over here, A and B are filled with water. Both the vessels are provided with pistons X and Y. Okay, pistons are there, X and Y. The bigger piston Y will move in the upward direction with a greater force when the pressure on both the vessels is same. When the pressure is applied on X, the water will go down and it will go over here like this. But pressure on both the vessels is same, then this is based on Pascal. So let us understand it once more. A and B of both different sizes are connected by a tube completely filled with water. Both the vessels are provided with pistons X and Y. If we press smaller piston X with force F, the bigger piston Y will move upwards. Okay, then Y will move upward and the direction with great force. But the pressure on both vessels is same. This is about the Pascal's law. Atmospheric pressure. Okay, let's solve this question. Why do we feel light on our feet when standing in a swimming pool with water up on our armpits? Because water is exerting pressure. Even atmosphere is also exerting the pressure. Atmospheric pressure. The earth is surrounded by a layer of air absorbed in the height about 300 kilometers. And this layer of air around the earth is known as atmosphere of the earth. As we gradually move up, the density of the layer of air continues to decrease in a particular height. This density reduces reduces to zero at a time. Beyond there is no atmosphere, means out of exosphere. Anything which has mass will exert force. Of course, we know anything which is having mass, it will exert force. We know air also has mass, so it exerts force on the Earth's surface, on other objects as well. The thrust acting on a unit area of Earth's surface on all the objects on the Earth's surface is called atmospheric pressure. In the SI system, the value of atmospheric pressure is million Newton meter square or million Pascal. This is actually a tremendous amount of pressure. You may imagine it to be equivalent in 2 elephants sitting on your head. That's so much of pressure. But our body can sustain it. Why? Because our blood is also exerting the pressure from inside our body. To prove air exerts pressure, let us again do the activity over here. Just read the activity. It's so simple. This vacuum. So, here's the activity and all. So here again, when vacuum activity is there, like all the air is removed, and this thing will crush because air is exerting the pressure on the can. Now, do you know every person is under pressure of air equal to the pressure of 2 elephants? But how are we able to stand in so much amount of pressure, and why it did not press us down? This is due to the breathing, which air creates pressure inside our body as well to balance the atmospheric pressure, as I told you right now. Effects of atmospheric pressure. The rubber suction pads are used in hanger knobs. We know that they are used for hanging clothes and all. This is a suction pad that is pressed against the flat surface. Air between the pad and the wall is forced to move out. Thus, vacuum is created. Whenever vacuum is created, these things happen. Okay. Therefore, it is firmly like over there. Even the sucker. Okay, vacuum is developed between the pad and the wall, so there is no pressure, very less pressure inside the pad acting upon outwards. Therefore, the atmospheric pressure from out is still acting on it. The outside pressure is being greater. The sucker is pushed firmly inside and it fixes to the wall. Due to atmospheric pressure, the ink gets sucked up in a fountain pen. Of course, lizards are able to move on the wall and stay whenever they feel like due to suction pads like section in their feet. Due to atmospheric pressure, the liquid rises in the syringe when the piston is pulled up. Injection syringe, like when it is pulled up, the air is coming, the liquid comes. Okay. Nose bleeding is common phenomena at the high altitude. The atmospheric pressure is low at the high altitude, but the body is exerting the pressure. Okay. Thus, the pressure inside the body is higher and the atmospheric pressure is less. Therefore, the arteries or the veins bursts and they releases blood. Okay. Air pressure helps in drinking with a straw. Of course, when we suck the liquid, the vacuum is created, the air is pushed out like this from the straw. The astronauts and the mountaineers are having special type of outfit to protect themselves from adverse effects of low pressure prevailing at a greater height. Astronauts actually have to go beyond the limits of atmosphere. There is pressure on their bodies will become negligible. Like this makes it necessary for astronauts to put on their special type of suit. Measurement of atmospheric pressure. Atmospheric pressure is not the same at all places. Experiments have shown that atmospheric pressure is maximum at the sea level, and as we go higher in the terms of altitude, that is towards mountain, the atmospheric pressure gradually decreases. Therefore, manometer is used to measure the pressure applied by liquid and barometer is used to measure the atmospheric pressure. Okay, the instrument which is used to measure the atmospheric pressure is called barometer. In 1643, an Italian scientist named Torricelli invented a simple barometer and hence was able to measure the atmospheric pressure at different places. Simple barometer. To construct simple barometer, we need a narrow glass tube, length nearly 100 centimeter. So like this over here, and it will be easy for you to. Vacuum is known as Torricellian vacuum. Okay, let us see it. It sounds interesting. We fill it completely with mercury. Okay, mercury, and ensure that no air bubble is left inside. So this can't be done by us because it is asking for mercury and all. Let the level of mercury in the tube edge centimeter above the level of mercury. Okay, so this is just activity. Okay. So advantages of using mercury in a barometer. Mercury is the most ideal liquid for barometer due to following reasons. It is the heaviest liquid, therefore it rises only at the height of 76 centimeter. Balance the atmospheric pressure. It is very heavy liquid, therefore it rises at the height of 76 centimeter. Therefore it balances the atmospheric pressure. It does not stick to glass. Yeah, even it does not stick to glass and it gives more accurate reading. Mercury is opaque and shiny, hence easily can be seen through glass. Although mercury has many advantages, but it also has following drawbacks. It has a long glass tube, no protection to it, so it cannot be carried easily from one place to another. Even we cannot carry because it is so slippery. It requires zero adjustment before taking reading. Yeah, the mercury should be at bottom level. The barometer tube must be kept vertically to get the measurement correctly. The container in which the glass tube is inverted is open from the top so that impurities may fall into it, making the mercury impure. Okay. As a result of these drawbacks, another barometer is known as aneroid barometer is used. Yeah, there are two types of barometers we studied, mercury barometer and aneroid barometer. It is convenient and impact barometer. It does not require any liquid and all. It has an airtight, partially evacuated sealed metal box with a thin top. The metal box with a thin top acts like a spring and increase in pressure. The top thin material sheet down while the decrease in pressure the metal sheet goes up. The spindle, lever and pointer. So like when it is airtight, I mean it is totally evacuated sealed metal box with a thin top, metal box with a thin top like a spring, increase in pressure, the top thin metal sheet will get down, okay, decrease in pressure it will get up, okay. An aneroid barometer can also be used as altimeter with tight modifications. An altimeter measures the height altitude of a certain place. The pressure decreases by 1 centimeter for every 125 meter increase in height. We call it something laps, 1 meter lap, something like this. It was in geography. Okay, let's read it. As we go up as we grow up, okay, for every 125 meter, the pressure is decreased by 1 centimeter. Pressure at places is 66 centimeter. It is less by 10 comparatively to the pressure at sea level. Therefore, the height place will be 125 into 10, 1250 meter above the sea level. Hence, the scale of aneroid barometer, which indicate the altitude meter, is referred as altimeter. So, this is the altimeter. Sorry. The scale of this scale. Okay. So, recapitulation. Let us recap what we started. The force acting normally on a pressure on a surface is known as thrust. Thrust acting per unit area is called pressure. The SI unit of pressure is Pascal. To increase the pressure, either force has to be increased or the contact of area should be decreased. Liquid pressure in a vessel increases with depth. It increases with the density. It is also depend on the acceleration due to gravity of the place. The liquid seeks its own level. Pascal's law states that pressure exerted at any point an enclosed liquid is transmitted equally undiminished in all directions. Means when the pressure is exerted at any point in an enclosed liquid, it is equal. The thrust on a unit area due to column of air on Earth's surface is called atmospheric pressure. Barometer measures the atmospheric pressure. Manometer measures the liquid pressure. An aneroid barometer is convenient, compact instrument. It can also be used as allimeter. Mercury is the heaviest liquid. So, mercury is the heaviest liquid and hence most suitable for using in barometer. It is also suitable as it do not stuck to the glass. Liquid and gases exert pressure in all the direction. The pressure exerted on the wall of a container also. The pressure at depth in liquid of density D in given by pressure is equals to H into D into G, where G is acceleration due to gravity. Atmospheric pressure is the envelope of the air around the earth, which is about 300 km high above the earth's surface. Atmospheric pressure at the sea level is 76 centimeter or 0.76 meter mercury column. So let us test our knowledge. Write true or false for the each statement. Rewrite the false statement. Okay, we'll not rewrite false, we'll just write true or false. Pressure is inversely proportional to thrust and directly proportional to the area of contact. False. Pressure is inversely proportional to the area of the contact and it is directly proportional to the thrust applied. A liquid seeks its own level, of course. True. Manometer reading remains the same for different positions at some depth inside the liquid. False. The horse can run faster and easier on the desert as compared to camel. False. Bulldozers do not damage the ground as much as cars due to their big wheels. True. All states of matter exert pressure. True. By making a knife sharp, we decrease the area of contact, hence pressure is increases. True. When we move from sea level to high altitude, the atmospheric pressure increases. When we move sea level to high altitude, the atmospheric pressure increases. False. The atmospheric pressure decreases. Dams and high-rise buildings have a broad base to reduce pressure. True. An allimeter measures the pressure of liquid. False. J. 2. Fill in the blanks. So, force acting normally on a given surface area is called thrust. Pressure is directly proportional to the area and directly proportional to the altitude. Liquid pressure remains the equal in all directions. So this rest is a homework for all of you. I will solve in my notebook and this is your homework. So thank you so much for visiting this channel. If you like this video, please subscribe to my channel. Thanks.